Recording in progress. Hi students, in this lecture I am going to discuss problems. Let us see first one. A circular road of radius 5 meter has the banking angle 45 degree. Find the speed of the vehicle so that no friction acts on the vehicle. It's a very direct question. Radius is given, angle is given, angle of banking, asking speed for which no friction acts on the vehicle. See carefully. Just recollect once what we have discussed in banking. So we have discussed that we are taking the banking angle in such a way that even there is no friction, we can take turning safely, right? So then we got tan theta equal to v square by arch. So we have taken the banking angle in such a way that even though there is no friction, vehicles can take turning safely. So in this you can see road is AC. Okay. So according to this given angle 45, so tan 45 that is 1 v square, r value given 5 meter and take g value 9.8. That implies v square equal to 49, right? 5 into 9.8. That implies v equal to 7 meter per second. So for this velocity, there is no friction on the vehicle. Suppose velocity is now greater than 7, then what happens is is having tendency of slipping off the road. Then friction will be down the road. Okay. If the speed is less than 7, vehicle is having a tendency of slipping down the road. Then friction will be up the road. Okay. See next problem. The radius of curvature of a road at a place where a vehicle moves with a speed of 36 kmph is 1000 meter. Find what height the outer edge of the road should be elevated if the width of the road is 1.5 meter. Given speed 36 kmph, radius of curvature is 1000 meter, right? And width is 1.5. Let us see. So first of all, so here road is AC. Vehicle is moving into the plane of the boat or out of the boat, and we can see here the length of BC, that is what we call height. By what height the outer edge of the road should be elevated? H value how much? Okay. So first write down given data. Speed is given. Speed is given as 36 kmph. So convert this into meter per second. See how to convert this. 36 into kilometer means 1000 per hour. 1 hour means 60 into 60, right? Seconds. So converting into meters and seconds here, okay? So kilometer means 1000 meter. 1 hour means 60 into 60. So 60 minutes and per minute 60 seconds, right? This is now 36 into, so 2 zeros 0 0 Cancel here. Remain 10 by 18. That is a, sorry, 10 by 36. That is a 5 by 18. That means we have to multiply with a 5 by 18 to convert into meter per second. This is now 2 times. This is equal to 10 meter per second. And given radius of curvature. That means when vehicle takes turning, that is a part of a circle of radius 1000 meter, right? Speed is given. So h value we have to calculate. Let us see what we have learned. So we have learned that tan theta equal to b square by rg. Tan theta equal to b square by rg, right? So tan means opposite by adjacent side, right? But here we are given width of the road, that is 1.5 meter. This is width of the road, right? Then see what we can do here. First of all, calculate what is the theta value. B square by RG, B square. B value is a 10. So B square 100. R value 1000. So 10 for 3. G value 10. Okay. This is equal to 1 by 100, right? So tan theta equal to 1 by 100. So whenever theta is very small, tan theta approximately equal to sin theta. Let us see why it is. Tan theta equal to sin theta by cos theta. Since theta very small, cos theta becomes 1. Therefore, tan is approximately equal to sin theta. I hope you got that clarity. Tan equal to sin by cos. Since theta very small, cos theta becomes approximately 1. Therefore, tan is approximately equal to sin. So here what I can do is sin theta equal to v square by rg, right? In the place of a sin, we can write from diagram, it is h by width of the road. Take it as w. W stands for width of the road. So from this I can write height of the road, that is equal to w into v square by rg. Remember, this is only for small angles. This is only for small angles. So width is given, v value, it is given 10 meter per second. R is known, G value is known. So we get the value of H. Okay. See next one. A block of mass M is kept on a rough horizontal turntable at a distance R from the center of the table. Find at what time block starts slipping on the table if the table rotates at a constant angular acceleration alpha and coefficient of friction is mu. So condition is at t equal to 0, angular velocity is 0. Okay. So it is a horizontal table. Distance is r from center. At what time block starts slipping? Starts slipping means frictional force becomes limiting friction, right? Constant angular acceleration alpha. Let us see. We have to find at what time. Right. First of all, focus how many forces acting on the block. This is now turntable. It is placed at a distance r from center. When we see from the top mg into the boat, means mg is vertically downwards, normal reaction upwards. These two are balanced. mg is downwards, normal reactions upwards. These two are balanced. Now in the plane of that table, there is only one force acting, that is a frictional force, right? And students, you should be very careful here because it is given constant angular acceleration. That means tangential acceleration is not zero, it is non-zero. See carefully, the only force acting on that is friction, right? There must be centripetal force towards the center. Centripetal force. There must be tangential force along a tangent. These two are in the plane of the table, right? And we are knowing that there is only one force in the plane of the table, that is friction. That means one component of friction provides centripetal force. Remaining component is now tangential force. This is what we have to understand. So frictional force is not towards the center. This is now static friction. So one component towards the center provides centripetal force. One component along a tangent, that is tangential force. The resultant of these two is frictional force. So I am writing here. The resultant of these two is static friction, which is equal to, let us take mass outside, m into acceleration is square root of ac square plus at square. So whenever we are taking circular motion, acceleration is having two components, AC and AT. So now we have to take resultant of those two, right? Now here he is asking at what time slipping starts. Slipping starts means we have to consider frictional force's limiting value. So I am taking here mu s into normal reaction. Normal reaction is mg. So mu s into mg, that is equal to m into square root of, in the place of AC. See what we can write here. Condition given that t equal to 0, omega 0. Let us take a time t, omega equal to u plus, means it is omega 2 equal to omega 1 plus alpha t. This is omega as a function of time, right? So AC values are omega square. So it is now r in the place of omega alpha t, that is AC value. AT value is now R alpha, and condition given that alpha is a constant. So substitute values here in the place of AC. It is R omega square AC whole square plus AT square. AT means R alpha, so AT square. Now remains the calculation part. Mass gets cancelled. Square on both sides. We get mu s into g whole square. And I am taking this square of r alpha left side. That is equal to r square omega power 4. Right? Now see carefully. R square Now what I can write here, omega power 4 is equal to 1 by r square into 1 by r square into mu sg square of that minus r alpha whole square. Okay. So from this omega value, I can take omega value as whole power 1 by 4. Okay. That is omega value. But omega equal to alpha t, right? Therefore, t value, t equal to 1 by alpha 1 by alpha, remaining value 1 by r square, square of mu sg minus r alpha square. So this is a time at which slipping starts, because we have taken when friction becomes limiting value, then block starts slipping. So here key point is that friction is providing both centripetal force and tangential force. So resultant force is nothing but frictional force. So net force is mass into acceleration, and remain just calculation part. Okay, let us see next one. A car goes on a horizontal circular road of radius r, the speed increasing at a constant rate a. Given road is a horizontal and circular, radius is capital R, speed increasing at a constant rate a. So a is nothing but tangential acceleration, right? The friction coefficient between the road and the tire is mu. Find the speed at which the car will skid. So this is almost same as the previous question. Let us see once how to calculate speed at which car will skid. So again here, forces acting on the car, mg downwards, normal reaction upwards, both are balanced. The only force in the plane of the road is friction. Again, same as the previous one. Centripetal force towards the center, tangential force along a tangent. Resultant of these two is nothing but frictional force. One component of friction provides centripetal force. Why Fs means it is now static friction. Okay. So one component provides frictional force and one component provides tangential force. Resultant of these two is static friction. So m into square root of AC square plus AT square. So now I am writing here, we have to find the speed, right, for which vehicle starts skidding. That means friction must be limiting value. So which is equal to mu s into normal reaction. And normal reaction equal to mg. So m into m gets cancelled. AC value v square by r. So AC square plus AT square, and given AT, that as A. So it is now A square, right? Now we want to find the value of V. So take square on both sides. V power 4 by R square is equal to mu SG whole square. It's almost same as the previous problem. Next, v power 4 equal to r square into mu sg whole square minus a square. Therefore, v value, it is r square into mu sg whole square minus a square whole power 1 by 4. So I hope you got clarity. The previous one and this one, all both are same only. Only change there we have taken the place of AC r omega square, right? And here we have taken b square by r. So remaining as it is the calculation part, right?